right, Peter. Thank you for joining me today for our presentation about how to create a fixture for CNC milling using generative design in Fusion 360. Peter, we have worked together in the past, and it's really nice that you're helping us out for this virtual event today. And so I'd like to say thank you for joining us. How are you doing today?
Yeah, doing really well. Thank you very much. Yeah.
All right, good. For those of us watching today, Peter and I worked together on a project some time ago to use additive manufacturing techniques to assist people using subtractive properties, subtractive manufacturing methods. And we felt like it was a pretty interesting approach. It was efficient, it was unusual and unexpected. And at the same time, it was also a really good use case for generative design, and it was one that we didn't really expect, if I'm quite honest. So we're going to show that to you today. My name is Mickey Wakefield. I am the Fusion Community Manager for Autodesk 360 in Europe. And Peter, about yourself, who are you?
I'm the Additive Manufacturing Manager here at Matsuura Machinery, and we are the HP reseller for production printers here in the UK.
And if you guys ever have the chance to get up to Colville in the UK and see their facility, I'm telling you, it's pretty special. It's they've got really almost like an automotive showroom for their machinery up there, and it's impressive to see. And it's a nice bunch of guys, and they really know what they're doing. So it's worth a trip if you're in the area.
Absolutely.
So this is that showroom I was telling you about, and this story is a story about Matsuura UK Ltd. It's important because these guys were the ones that came up with this idea, and they assisted us with the workflows, generating workflows to make this fixture. And so you can go to Colville and you can see this facility, you can see those machines. Peter, tell us about Matsuura UK Ltd. and where you guys come from and what you've been doing all these years and where your expertise lies.
Well, obviously, Matsuura is famous for the best machine tools that are on the market, and we're used to being metal cutting. And I think nearly 2 years ago now, we started out as a reseller for HP, and it was a strange marriage. And I think some people kind of thought, why? And I think we took our expertise and we applied that to selling HP printers, and that's really where the fixture story came from. It was for us to try to show the strength of the plastic. Everybody perceives that plastic is weak. It's just for prototypes. So coming up with the story for, actually making a fixture to produce a component on, I got to say, a lot of people in Matsuura laughed. But wow, they were wrong.
Yeah, and this is the team. You can see Peter there on the far left. And the rest of the team here, Kevin Shaw in the back from Autodesk, Ian Mitchie, and Clive Smith. These guys were involved in this project. And there are some YouTube propaganda videos out there where you can see how we made this look good in a filming day some time ago. But you can see everybody smiling, so we got something done really nicely. Now, what is this that we did? Now, this was a test example, right? I mean, this is not a real production part, although it most certainly could be. But at the time, we were sort of investigating workflows to figure things out and how that might work. And so what you're seeing here on the left is a subtractively milled part, a CNC milled part in aluminum that we thought might be a good candidate just for testing things out. And it needs a fixture to hold it. Now, it's not a very complicated part, but the idea of generating a fixture, as you see here on the right side, using Autodesk Generative Design in Fusion 360, using a polymer from the HP printers that Peter has available to him and can make available to you. That was an interesting prospect. And you can see what we got out of this. Looks very organic and very interesting. But what's more important than how cool it looks is the fact that it was designed using an algorithm. So somebody didn't actually sit down and have to figure out how to make that geometry, make that shape. It was created by an algorithm, that is generative design in Fusion 360. And that algorithm intends to create geometries that are not only manufacturable by the machinery on hand, but is also strong enough to withstand the forces that this part is likely to see during machining. So, Peter and I, we're going to show you kind of how we did that. This is that part all on its own. That's kind of the showpiece part that we made. When you are working in generative design, really, we're not talking about creating parts. We're not talking about modeling parts. We're talking about giving a computational space which the computer can use. And so one of the first things we have to think about conceptually is about where do we have to have geometry where we must have geometry, and where do we have places where geometry cannot exist. And this is unusual. This is a little bit difficult for people who are starting out with generative design in Fusion 360. And so conceptually what we're thinking about here is, well, if I'm going to bolt this thing to a table, if I'm going to clamp it down somehow, then I need to have a place for those bolts to go. If I'm going to have bolts, I need bolt holes. So we need to think about creating geometries that are preserved geometries that we must have. And this would be one example of that, fixation to the machine. Continuing further, we also have to think about, well, where are we going to connect to the part that we're going to manufacture, the billet of material that we're going to manufacture. And so we would, in general, actually also look about keeping that geometry in as well. And these are the things that we're going to model within Fusion 360. Or if you prefer in Inventor, we can also work with Inventor data inside of Fusion 360. So we can import that Inventor data into Fusion 360 and use the generative design software using Inventor data as well. Peter, I'm going to ask you in just a minute how this was for you. So think about that first experience, the first time I asked you to sort of generate something without actually creating a CAD model. That's coming up soon.
Okay.
All right. And the other thing that we have to think about is we need to think about, how do we actually access this material that we're going to machine? Where do we have to make sure that we have free space such that our cutting tool can actually reach the material? And this is a little bit more difficult to think about. We have to think about the tool paths, and we can generate those in Fusion 360 as well. And we have to think about, where are obstacles in our machining area. And so we would generally do this by creating obstacle geometries. The very basic one you can think about is like connector obstacles. So if we're going to put bolts into our bolt holes, I always use very simplistic language on purpose. We're going to put bolts into our bolt holes. We need to have space in our geometry to actually slide those bolts in. So as you can see, we have extensions above the mounting points such that we have room to put the bolts in. And not only that, on occasion, I will actually create these red geometries even higher so that I have space for a tool with which I can tighten these bolts or screws or whatever this may be. Keep in mind, this technique can be used for all sorts of applications, not just creating fixtures. And once we do this, we have to create also an obstacle for the table itself, because we can't, of course, reach the part to be manufactured underneath the table. That's not possible. And we have to have the billet of material, which we're actually going to cut later as well. So these are our obstacles, and this is actually the geometry that you feed into Fusion 360 in order to create a geometry that incorporates the green stuff but leaves the red stuff out. And Peter, what was your experience the first time you saw something like this? How did you feel about this? Was this super easy for you to get your head around at first, or was it a little bit difficult?
For me, actually, I thought it was quite easy. It was a concept that I understood from the word go, and I had a clear vision actually for what I wanted out of it from a fixture. I wanted something super organic, super sexy, and we got that. But actually, our existing applications engineers, They were a different breed altogether. They were like, whoa, we make metal fixtures, we design fixtures. Plastic cannot be used as a work holding. So I was the one out on the limb with the idea, with Fusion 360 Generative design. I knew where we'd go, but I think I was the only one.
Well, Pete, that's why you get the big bucks, right?
Absolutely.
All right. Well, my experience is, the first time I met Peter, it was clear to me that he really did have a pretty good handle on this. But I'll tell you, this is one of the things that if you're getting into Fusion 360 the first time using generative design, this is typically one of the things that does cause people a little bit of a headache. It does take a time to get your head around it. And we do offer courses on a regular basis, virtually now with COVID-19, or also once the zombie apocalypse has passed, we do offer in-person courses in our Birmingham facility where you can spend up to a week with our engineers and learn how to use this software quickly and efficiently. So just keep that in mind. You can talk to your Autodesk guys about that if you're interested. Now we've got obstacles and we've got preserved geometries, but we also have to think about, what are the forces that we expect our generated geometry to actually withstand. And so we actually have to give the system some information about where are we holding this part. That's obviously at the table. We're going to be fixing it on the table. But we also have to tell it loading situations. And of course, parts can have many loading situations. So I took information from Ian Mitchie, another Matsuura UK employee, about the loadings they had typically experienced on a part that was machined in aluminum, like this one. And I put those forces into our perspective geometry at the locations I would expect to see them take place. And we actually have the ability to put in many different loading criteria. So I had, I believe at the end, over 20 different loading criteria, which I expected the billet to see. And then my next task was only to describe the types of materials that I would like to use. Now, I have to be honest, Peter knows this. We always knew what kind of material we were going to use at Matsuura UK Ltd for this, right, Pete?
Yeah, absolutely. We were going to stick with a polymer, PA12, and we had confidence in the way that HP Multijet Fusion applies that material to produce the part is very much different, and we had some confidence that we could produce a part just in nylon alone.
Yeah. So the reason so in actuality, when we did this, we only used one material type. In reality, for most people, a lot of times there's sometimes you have a situation like that. What we show here is that we, as an example, we show 3 different materials. And what the software will actually do, will try to create a geometry that is suitable from each one of these 3 materials. And so you could actually do, I believe it's up to 8 different materials now. So you could try out 8 different materials. So you might try one in a metal. You might try one in a polymer of some sort. You can search any kind of material you like, and the software will attempt to give you a solution based on the loadings and the geometrical constraints that you put in. But in our case, we actually only had the one. Now, in our particular case, we knew from the get-go that we were going to print this thing on an HP machine, and we knew that was the case. And so that's what we told the system we were going to do. We told it we were going to use an additive manufacturing process. And so the geometry that's created is an attempt by Fusion 360 to create geometry that is actually able to be manufactured using the equipment on hand. But just because we did this as an additive manufacturing model doesn't mean that you have to. We had, at the time, the ability to also tell the software we're going to use 3 or 5-axis or 2.5-axis cutting. And that was those were possibilities we could put in. And we now actually have die casting and a couple of other manufacturing capabilities as well. The point of this being is that this is where a lot of the really high powered calculations inside the software are happening. We don't just attempt to give you a topologically optimized model. We actually try to give you a topologically optimized model that can actually be manufactured using the equipment that you have on hand. And that's the big clue behind Fusion. And what makes it different from a lot of tools that are similar out there on the market. Once you've set all this up, it's quite a lot of calculations. Fusion will do a calculation for every material provided, for every manufacturing method defined, and it will do so iteratively. So it has to do, for each one of these, it has to do at least between 25 and 150 different iterations to come to a usable result. And for this reason, we do not run these on your local machine. That would take donkey's years. I mean, quite literally, you'd be looking at days worth of calculation time. So we send these to the cloud. We make use of Amazon Web Services cloud computing power. And because we have to pay for that, we do charge cloud credits in order to use this generative design technology. And that's 25 cloud credits. To be honest, cloud credits are sold in US dollars, so it's always a little bit difficult to figure out exactly what that is, but 25 cloud credits for a generative design calculation, that is more or less about 25 euros for a calculation like this. And so that remains unchanged no matter how many materials or how many manufacturing criteria or how many iterations you need to do this. And usually within the space of 20 minutes to a couple of hours, you get results back. And do you remember when we got our results back, Pete?
Absolutely.
Yeah. So you get all these results and you can look at them and you can sort them based on different criteria, and you can see how they're made. They're all different. But the idea being is that you get information about which ones work. You also get results that don't work. That's also true. You can show results which did not converge. So if we tried to make this thing out of bubble gum, which you could technically do, it would tell you this is the best result I could give you, but I have a safety factor that is well below that of what you desire. And that result would be complete because all the mathematics are complete, but the result would not be converged. And what you're seeing here are completed and converged results, and we chose one that we liked the best. In reality, all of them would have worked, but we picked the one that was the best for us. And if I'm honest, Pete, I think you'll say the same thing. We chose the one that just kind of looked the coolest at that point. You know, we had a whole lot to choose from.
Yeah, we did want that. We wanted that organically produced, sexy fixture that we had in the mind from the get-go.
Exactly. And so that's the one we picked. And here's the other thing about these things. When you download them, it is a unique feature, as far as I'm aware, of Fusion 360 Generative Design, that the files you download from Amazon Web Services, those are what we call B-reps. That's a fancy CAD speak for a real CAD model. And that's important because in general, with topological optimization routines that are commonly available on the market, you will get what's called a mesh file. It's often an STL or an OBJ file format. And these mesh file formats are very difficult to edit. They can be difficult or impossible to edit. And we have an integrated conversion software in the program which converts these to a B-rep. And making them a B-rep means that you actually have the ability to make modifications on this. Not only do you get a B-rep, you actually get feature information out of this. And for those of you that are adept or will soon be adept at using T-splines in Fusion 360, you can actually modify and manipulate these organic forms in an organic fashion if you so desire. And I believe, Peter, we actually did make a few small changes to this thing, right?
Yeah, we just had I think they were minor cosmetic changes just on the way that the feet sat on the bottom. And we put some home symbols and things just to make it a little bit easier to use. So yeah, very, very easy to manipulate that model.
Yeah, that we didn't. One of the things we liked about this project so much is we kind of got a result out of the computer. I believe it took about 4 hours to run. We got a computer result out of the computer, and we just pulled it. And I think what was it, Pete? I think about an hour or two later, we were printing it up. Right?
Yes. Yeah, absolutely.
We didn't have to spend a whole lot of time. This is Pete in his world putting the machines together, and this is actually the part being printed. Right? This is the part being printed in the space at Colville. And this is Peter doing what he does best to clean that thing up, taking out the machine. This is totally not faked. And Peter, you did color it, right? You put in a dye machine, right?
Yeah, we did. You don't have to. You know, the multi-jet fusion material is watertight and pressure tight, which surprises some people, but that tells you quite how good the material is formed. And here you can see it in the grey, perfectly usable. So yeah, we did indulge with dimension because we have that kit here. We applied a lovely black dye and a polish to it, purely to sexy it up a little bit more, even if it couldn't be any more sexy. But yeah, so a little bit of indulgence, unnecessary, but yeah, wow, you know, it's such a lovely part.
And I think what I liked best about this project, quite honestly, and we have a lot of projects. I work on all kinds of projects at Autodesk. This is true. And I'll be honest, a lot of those projects are difficult. I mean, there's a lot of value in doing really difficult stuff where I have to call in a bunch of experts and slave over something for a couple weeks and kind of figure out how to work it and everything. That's really valuable. But what I liked about this project was it's pretty easy, right? I mean, we set it up and we created a fixture without ever touching the CAD. Pulled it out of Generative Design, put it in the machine, and how long did you print that thing up on your machines there?
It was about a 10-hour print cycle, 10-hour call, so 20 hours fixture in your hand.
Yeah, I mean, I remember we were there. I think you were already printing a version, an earlier version when I came. And then I think overnight we printed a second one. And on the next day, the filming that you saw there of us cutting, that was actually on the second day. So I only had to stay in the Holiday Inn in Colville one night, which, it's okay. It's a breakfast. It's okay. It's all right. So, Peter, are there any opportunities for people who are interested in this to talk to you at Matsuura UK Ltd about CNC manufacturing using Matsuura machines or additive manufacturing using HP machines? Who should call you and how should they get in contact with you?
Obviously, anybody within the UK can contact us because we cover the UK for HP and for Matsuura. I'd love to say we cover the rest of the world, but even if you don't, you contact me anyway. We can always put you in touch with other HP partners. It's just been a great story, really, to be involved in.
And for as a point of interest for everybody else, this actually did cause a lot of commotion inside of Autodesk as well, because it wasn't really an application that we were thinking of when we created Generative Design, but we found that the application was so good that we are now investing some time in research to further automate the process of creating fixtures. And hopefully, if we get all the stars lined up right, we can automate this process even further so that at some point in the future, you may be able to create fixtures with even less effort than this. So right now, we can do this with Fusion 360 and Generative Design. And we're hoping to make use of this technology and some of the expertise that Matsuura so kindly gave to us to further improve the software for everybody's use. And I would like to just say thanks again to you, Peter, and to the rest of the people on your team. It's always been a pleasure working with you. It's quite a lot of fun. And I hope that when all this is over, I can be back up and visiting you guys soon because it's quite a nice place to be.
You're very welcome. And it's, I think we were surprised by the story and quite how Autodesk took it on. And one little fixture has become, a worldwide almost phenomenon in its own right. And I think because we set out on the mission purely to prove the strength of the plastic, it wasn't really the fixture story that was key for me when we started it. It was just purely trying to disprove that myth that plastic isn't strong. And this sort of global phenomenon fixture came out of it. And it's a story, and it's been printed in so many different countries. But as you say, the story really has come out, which is, and we're still sharing it day to day now. If people come in and go, yeah, I've got my HP printer now, I've got my machine shop, but it still takes me 2 weeks to design fixtures. And, you know, we have Autodesk that come into our showroom still. And when we share the simplicity of it, they go, wow, you know, so the true story has been the generative design, the Fusion 360, but the star of the show has been, for me, the HP Multijet Fusion plastic fixture.
Well, I think you're absolutely justified in thinking that as well. And that's one of the things I like personally about this story, because it brings people together that you don't really think. A lot of times I see people that are in CNC shops. I can name a couple, but I won't. Right now, they're telling me, oh, that additive manufacturing stuff, we don't need any of that. We're a CNC shop. We do everything CNC. Well, you know what? You've proven that the two can and should probably, in some cases, be working together. And I think that makes sense. We can show that generative design was really created as a structural analysis program that was supposed to help people create complicated parts that are under strong loading. We initially envisioned it as a way to reduce the number of parts in complicated assemblies as well. And, we were kind of blown away about this as well, making fixtures with it. It wasn't something we really thought about. And I'm really happy about the fact that, we're proving that polymers can be used in places where people do not currently see them. And I think that that's a trend that is bound to continue. I think we're going to see a lot more of that. And so I really like this project. This is actually, I'll tell you, Peter, of all the projects I've done, this is my fave. This is my favorite because it's easy, it's unusual, and it brings a lot of value to the people that do it.
Absolutely.
Thanks for your time today. And thank you for everybody watching out there. I hope it was enlightening for you. Again, my name is Mickey Wakefield. At Autodesk, you can reach me at mickey.wakefield@autodesk.com if you so wish. And Peter?
I'm Peter Harris, Additive Manufacturer here at Matsuura. And actually, if you go to matsuura.co.uk, you can contact us through that website and we'll deal with your inquiries. And if it's not us that can answer the questions, we can pass them on.
Thank you, and have a good day, everybody.